As I said in previous talks, higher density or gravity causes the material to pack tighter together, and so there is less empty space within, right? So materials that have a higher density have higher energy. They are larger atoms. These larger atoms require larger amounts of energy to stay in their state. Because they require larger amounts of energy, they have to pack closer and closer together to reduce the amount of area or free space between each one of them to maximize the collection rate. And so, because of this, in this, when you look at different materials, you go from one material to the next material, right? So you go from air to glass. There's a big density difference between these two materials, and so in one material, you can fly around faster and still collect energy, right? No problem. So you can move faster and still get what you need. But when you go into a material with higher density or more gravity, your mass has to increase in order to maintain your energy at what it is. And so when a particle goes from one material to the next, it reduces in speed, and the energy that is lost in speed is converted into mass. This increases its mass in order for it to sustain itself in this different environment. And so greater mass, slower speed, same energy moves through this material, and then when it goes out the other side, say it's just a pane of glass, it comes out the other side of this pane of glass, it then reduces in mass, increases in speed because there's a balance there to maintain that same energy. And what happens is that you no longer need that mass to help sustain your energy level, and so you can reduce it back down and travel faster. When it's flying through there, I thought it would, since there's, in theory, higher interactions happening, it would also experience this. But it may be actually that there's less interactions happening, and so it has to increase its size it has to increase in mass in order to increase the amount of area it can cover in order to maintain its energy. Going into a higher density, stronger gravity field, you have to increase your mass to help sustain your energy. Outside of this higher density, more gravity material, then you can shrink your mass back down, because now there's more energy just kind of in this free space. It's less tightly packed because the material that you're in is not as energy demanding. And so you can reduce your mass, increase your velocity, which balances out your energy to be the same. But by doing this, you can maintain that same conversion rate to maintain your energy. So when you're flying along, you can travel faster but have just as many interactions. But if you were to travel that fast in the higher density, more gravity material, you would not be getting enough interactions to maintain that. And so in order to correct for this, the particle increases in mass, slows down in velocity to uh, correct for the change in conditions. I think that is the more logical and more probable reason. I don't think it's that it's getting more. I don't think it's that it's getting more energy, like I said before. Upon consideration, that doesn't really track. I don't think so. I think what I had previously just explained is my reasoning for why mass of a particle should increase in more gravity, and why particles that are higher in energy travel faster, and can have less mass depending on the materials, because they're traveling faster. They are able to achieve that interaction balance state because they're moving at a speed fast enough to sustain that, and so they don't need as they move faster, their mass can decrease because they're still keeping that balance of interactions to sustain their energy. And so, in theory, the slowest photons are the largest photons, right? And the fastest photons are the smallest photons, which seems to make sense, right? Because we think that the speed of light, which in a vacuum is the fastest anything can go, right? And we think that photons are massless. So it would make sense that this limitation would be a massless particle. But, then you get into the whole thing, well, what the heck is it, if it's pure, at that point it would just be pure energy, and at that point, it's not really a part of this universe, it's not really part of this reality anymore, as I've explained in other videos. And so, I think that although the current consensus is that mass is constant and weight depends on gravity, I think that if you did some testing, I don't know how precise this testing would have to be. I don't know if we could observe it, but I do think that you would find it to be the case. Again, I don't know on what scale. It's probably not a major difference. I mean, with the photons, it's single digits, and that's on a scale of literally like to the negative 34th power or whatever. So it's very tiny change. So maybe, we wouldn't notice it, but I do think that it's there, and I do think that it makes sense. And I do think that is important because it also helps to explain the difference in speed of light in materials compared to in a vacuum, compared to in air, and it also ties it all back to gravity and how that works, because not even necessarily gravity, but the fact of energy, dark energy, and energy density, and the energy that's inherent in certain materials and their collection and absorption of energy. A denser material has a higher demand for energy, and so they pack tighter together because there's very little energy to go around, and so the gravity of each molecule pulls them, or atom pulls them really close to each other, because there's not much else in between them, because they're absorbing anything else that's there pretty much as soon as it shows up. And so, you know, if if you're trying to capture something and, you know, there's only like 2 in your in your path, but there'll be 20 if you could stretch out your arms. You know, it makes more sense to stretch your arms out and you could catch all 20. You know, maybe you can't run as fast if you got to stretch your arms out, but you'll actually catch 20 rather than 2. So it just makes sense to do that, right? And that's basically what's going on with a mass increase. By increasing the mass, you're increasing your pull strength, which increases your ability to absorb energy, because really the absorption of energy is just a mechanic of gravity, and gravity is just the flow of energy between 2 points, right? And I feel like I'm starting to ramble here. So at the end of the day, gravity is defining, it's really not, gravity is really not defining this. It's the flow of dark energy from a point of higher energy to lower energy is really what is defining this and creating these behaviors and interactions. And we observe that more commonly as gravity, but realistically, is it really the classical gravity we're thinking of that is causing this behavior at such a small scale in this material? I don't know. Yes, but also no. Yeah, I'm gonna end it there. So, peace out.